So yesterday we kind of reviewed the distributive property just a little bit, and just to remind you, when we have something outside of the parentheses, let's say I have a 2, and inside parentheses I have, I don't know, let's say x plus 3. What happens with that 2 that's outside? This is like an implied multiplied, right? And it multiplies to everything inside when I'm adding or subtracting that way. So another way to write this would be 2 times x plus 2 times 3, right? So it would be 2x plus 6, right? And we talked about that a little bit yesterday, so I won't spend too long on that so we can get to the other good stuff in this lesson.
Oh, the timer.
Oh, no, thank you.
Oh, no problem.
No, thank you, thank you. All right, so sometimes I can use distributive property. Let's not do that. Let's go to like terms. To kind of simplify some things, okay? So let's talk for just a minute. We talked about an algebraic expression, right? And what it means to be an algebraic expression. Didn't we do that in 1-1? No or yes? Yeah. And an expression doesn't have an equal sign, right? But the algebraic expression has variables in it, right? So let me give you an algebraic expression, and I want to talk to you about it for just a second. Let's say algebraic expression. Let's say I have 3x plus 2 minus x. Is this an algebraic expression?
Yes.
Why?
Because there's a variable.
There's a variable in it. There's no equal sign. If it was an equal sign, it would be an equation. There's variables and there's operations, right? So it's an algebraic expression. What do we call the pieces within an expression, an algebraic expression? Terms, right? Terms. What do you notice about 2 of these terms?
They're both x.
They're both x. What do we call them when they look alike like that? A like term. Very good. So define, if you had to explain to someone who had never seen it before and didn't know at all what it meant to be like terms, what would you tell them? What's a like term? What's the same? The variable is the same. Is the number in front of the variable the same? No, it can have different numbers in front, right? If there is an exponent, though, the exponents on the variable must be the same also. Okay, so looking at this, now I don't see an exponent on these x's. Does it have an exponent?
No.
No?
No, it does. It's 1.
It's 1. It's an implied 1, right? Anytime you don't see an exponent, you can assume it's 1. So my next question is, we've determined that 3x and negative x are like terms because they have the same variable with the same exponent. How do I put them together? How? How do you combine? What do you add? Not the exponents.
No, you add the variable.
The numbers. What are those numbers in front called? Starts with C. Coefficients. We combine the coefficients and leave the variable alone. Okay? So if I have, and I'm getting somewhere with all of this, I promise I am. If I have 3x and negative x, I don't see a number in front of this one. What does that mean?
There's a 1.
There's always a 1. So how do I combine the numbers in front? What is 3? Patrick, I see your phone in your lap.
Patrick, put your phone away.
How do I combine 3x and negative 1x? What do they combine to become? 3 and negative 1x. 2x, right? Because I look at the coefficients in front and I say, what is 3 and negative 1?
4. Not 4. It was 2.
It's 2. That's correct. I love the enthusiasm and the confidence, though. So it is 2, and the plus 2 still stays there. So do y'all remember you should have learned about combining like terms this way, right? Okay. So hopefully you remember this. So when I'm in simplest form, I need to combine like terms. Okay, make sure everything's combined. So let me show you an example where we're going to use the distributive property along with combining like terms to simplify an algebraic expression. Y'all ready for this? Yeah. All right. Please be a little more excited.
Yeah.
I was just picking. Okay, but I do like for y'all to be excited. Let's do
Number 4.
how might I simplify this?
Just add the ones in the middle.
I could absolutely, well, there's not, either one of those ways is right. I could distribute first, right? Or I could do the parentheses first and combine those like terms. So we'll combine the like terms because that's what I heard y'all say first. How do you combine 3x and 2x?
You add them.
Okay, and it becomes what?
5x.
How do you multiply a variable term with a constant number? What? I hear you can't. Multiply is different than adding.
Oh.
You can't answer. What do you do? When you're multiplying, you're just going to multiply the coefficient here with this number, and it's going to be 10x. Okay. All right, let me give you a couple. I want you to simplify these if you can. Tell me what you can do to simplify if you can simplify it all. How about 7a plus 4 minus 6a squared minus 2a? Can that be simplified? Ooh, I heard yes right off the bat. Why can that be simplified? Or how can that be?
3 a's. No, there's 2 a's and there's an a squared.
All right, there's a 2a, and then there's a 7a and a negative 6a squared. What can go together and what can't?
7a minus 2a and that's it.
This one
And now.
and this one. Do we all agree? Do you see why? What does that become? 5a. Okay, I'm going to take this a little step further and tell you that as we get a little bit further in our math, the correct way to write this is to write it from the biggest exponent down to the constant. That's what we call standard form. So what should come first in my expression? But it's not 6a squared, it's negative. There you go, negative 6a squared. What comes next? Plus 5a plus 4. Yes or no? What you think? One more?
One more.
Uno más.
Okay.
4y to the third plus 2y minus 8y plus 5. Can it be simplified? Why?
Because it's 2y minus
There's,
8y.
I have some like terms there. Which one are like terms?
Why?
Which ones? The y.
But why are they like terms?
Why are they like terms? Because they're both y, yes. So 2y and negative 8y would simplify to what?
Negative 6y.
Y'all are on this. I kept the y to the third in the front because the biggest exponent is 3, so I kept that first, and then I went down from there. Questions? Don't be scared to ask. Don't be scared to ask.
Oh, I thought you said something else. Stop.
All right.